Hello, in this video I will demonstrate how to use the z-test to test the average difference between two means. We begin with the following problem, which states that a marketing researcher in the city of Pasadena is testing the average difference in wait times at two popular restaurants in the city, Houston's and the Granville. He claims that there's an average difference in wait times for people waiting to get a seat during peak dinner times from 5 to 9 p.m. Test the claim using alpha equal 0.01. We are provided with the sample data for Houston's, average wait time 35 minutes, population standard deviation 5 minutes, sample size is 30. For the Granville, the average wait time is 45 minutes, standard deviation 8 minutes, sample size is 40. Since we're given the population standard deviations, that means we can apply the z-test. So we first have to state the claim. We assign population parameters. Mu1 will represent the mean wait time for Houston's. Mu2 is the mean wait time for the Granville. And the claim is that there is a difference. Difference is interpreted as not equal. So mu1 is different than mu2. That's the claim. Since it's not equal to, that's also an H1 statement. H0 is that mu1 equals mu2. Next, we draw the normal distribution. And since it's not equal to, there's no direction, there's two tails. We look up the critical value in table F. So alpha is 0.01. Two tails, 0.01. We have to go all the way down to the very bottom of the column to find the z value, 2.58. So we have negative 2.58, positive 2.58. Next, we compute the test point. The formula for the test point is z equal to the difference of the sample means minus the difference of the population means. Let me go back and edit something here because we need to ensure that the second sample mean is x bar 2. And I just want to point out, let me just paste this down here because we need the difference in the two sample means, x bar 1 minus x bar 2, minus the difference in the two population means, all over radical sigma 1 squared over n1 plus sigma 2 squared over n2. And then we have to take note that the difference of the two population means is always 0. So let me cut that out. And so now we're ready to perform our calculations. We plug our information in from our sample data. We have 35 minus 45. The difference between the two population means is 0. We have 5 squared over 30 plus 8 squared over 40. Let's calculate this using a scientific calculator. Now, how I type it in, I type it all in one simple shot. I use parentheses. So I have 35 minus 45 encased in parentheses. I don't write the minus 0. That's just 0. So don't bother with that. Then divided by the square root, we have 5 squared. That's divided by 30. Plus 8 squared divided by 40. Hit enter and we get the z-value, negative 6.41. Now we just have to go back to our graph to see where it falls. Negative 6.41 is less than negative 2.58, so it definitely falls within the critical region. Thus, we reject H0. Finally, we summarize our results. If we go back, we can see that the claim is H sub 1, and I like to use the flow chart that I provided to you with the notes. Since the claim is H sub 1 and we rejected it, we can state there is enough evidence to support the claim. Thanks for watching the video.